Welcome to ERDC Live. I'm your host, Shelley Tingle with the U.S. Army Engineer Research and Development Center. Today, I welcome Dr. Cary Talbot with the Coastal and Hydraulics Laboratory and National Lead for the Forecast-Informed Reservoir Operations Program. Traditionally, reservoir operations have been guided by historical data and predetermined rules or schedules. However, these approaches can be slow to respond to changing weather patterns and hydrological conditions. Forecast-Informed Reservoir Operations, or FIRO, seeks to address this limitation by incorporating real-time forecasts into water management decisions. This innovative development has emerged from collaboration research between ERDC, NOAA, the USGS, the Scripps Institution of Oceanography at the University of California, San Diego, and more, including state and local water agencies. FIRO's approach to water management integrates weather forecasts into the operation of reservoirs, which are critical to maintaining and managing water supplies, flood risk management, ecological benefits, and hydropower generation. The continued development of FIRO is having a positive impact on reservoir operations in the western states by providing water managers with increased flexibility to adapt to weather and climate extremes, and will soon be applied across the nation. Welcome, Dr. Talbot.
Glad to be here, Shelley. Thank you so much for this opportunity.
And so, Cary, could you give us a brief description of FIRO and how this program got started?
Certainly. And let me just start off by saying I'm probably going to call it FIRO instead of FIRO, but it can work either way. It just kind of depends upon where you're from, maybe originally. So how it got started was, well, like many things, congressional attention tends to get focused when there's a disaster. 2012 to 2015 was the driest 3-year period on California history to that point. And there was attention given to, can maybe we find a better way, a better balance between flood risk management and water supply? You know, the way that, as you talked about in your intro there, that the Corps of Engineers was being a flood risk management agency. We have primary responsibility for providing flood risk capability or flood risk management capability. And most of the dams, certainly in the western United States, that the Corps owns and operates are built with that purpose. That they catch the rain when it falls, hold it until the downstream flooding concern is gone, and then they release, making room for the next storm that might come. Well, the question is that if we know that there's not really another storm coming, or at least not for in the near term, do we really need to release all of that water and get it all the way back down to that level, that lower level where we have room to store for a large event? So the question is that can we use forecast information, particularly with respect to atmospheric rivers, which by about the mid-2010s were recognized now as the driver of flooding conditions in the West? Can we use research into those atmospheric rivers to improve the capacity or be able to find this better balance between flood risk management and water supply? So that's what began in at the end of 2014. It was about in the fall of 2014 when we got started. And we started by forming a steering committee and we'd selected an initial pilot site that was Lake Mendocino. It's on the Russian River. It's on the East Fork, actually, of the Russian River in Northern California. It's about 100 miles north of San Francisco. And with that dam, it's a fairly modest-sized dam, but it had a lot of benefits in terms of being a good place to study and figure out if we could strike a better balance between flood risk management and water supply. And so that's where that effort began, with this carefully formed steering committee. Many of the agencies that you listed there, from the federal as well as state and local agencies, and then also, of course, academia, because the Corps of Engineers were not a meteorological agency, and so we needed expertise in that. We, of course, were working with our partners at NOAA, both from the River Forecast Center, which is more the operational arm of NOAA, as well as the Office of Atmospheric Research from Boulder, Colorado, the research side. But then we also brought in the Center for Western Weather and Water Extremes, which is a new center that was formed at UC San Diego. or just a little bit before that, with one of the world's leading experts in atmospheric rivers research, Dr. Marty Ralph. He's the director of that center. And so we brought together all of this research and operations to come together and figure out, well, what's possible here? Not just from the science side, what does current research and forecast skills support, but also what are the operational constraints, taking into account the fact that there's also biological constraints here as well. There was a biological opinion on releases from Lake Mendocino, so can't ignore the impacts that changes in water management might have on fish populations and their behaviors. So taking into account all of those different perspectives and stakeholder interests was vital to setting the stage for how we might be able to explore the viability of FIRO at that reservoir, and really any reservoir. We understood that starting this off, that was setting a pattern for how we would be able to then take it to other reservoirs around the country. So that was how we got started.
So you mentioned atmospheric rivers, and we know that atmospheric rivers provide like 50% of the annual rainfall in California and cause around 84% of the flooding, which results in a $1 billion annual cost that California is paying for flooding. So how exactly does FIRO reduce the flooding?
So that's a great question. And that 84% figure is accurate for the entire West, but if you're looking at certain parts of the western United States, like say from San Francisco northward to the Canadian border, it's actually even greater than that. It's more like 95 to 99% of the flooding can be directly attributed to when atmospheric river events are occurring. So how does that help? How does that help make FIRO possible? Well, since those are the flood drivers, those are the events, particularly in the rainy period, which in the West is essentially from November to March or April every year. If you're going to have flooding, it's going to be because an atmospheric river event is happening. And so there was a lot of research that was needed to figure out not just how do these atmospheric river things work? And it's a fairly new term. A lot of people may, I think more people are becoming more familiar with it, especially after this past winter. However,
Super Bowl.
Yeah, that's right. But prior to that, really that term didn't come about even until about the mid-90s. So that's when the literature started recognizing that there was this meteorological phenomena called an atmospheric river. And they really are that. They're quite literally a river of water vapor, in this case, not liquid water, but water vapor in the sky. Up to 25 times the Mississippi River, an average atmospheric river. If you were to cut a cross-section and figure out how much water is moving in them, they tend to be low in the atmosphere. These are all things, by the way, that I learned from my colleagues, my meteorological colleagues. This isn't my area of expertise, but they tend to be low in the atmosphere, about 5 to 10,000 feet or so. And they're literally tropical moisture that it gets pulled up into the higher latitudes and then flung in a narrow band towards a continental body, right? In this case, the west coast of the United States. But they actually can happen really all over the world, and even striking the United States in other parts. They can come across the Gulf of Mexico and impact this part of the country where we are here in Vicksburg, Mississippi, as well as up the eastern seaboard, and then Europe, other parts of the world as well. At any given time, my colleagues tell me there's usually about 4 or 5 of these happening, and they're responsible for about 95% of the movement of water vapor from the tropics towards the poles in either hemisphere. So they're a very important phenomena for driving weather, not just as that atmospheric river hits the west coast, but then as that water vapor makes its way across the continental United States. So investing research in investing money to research these helps improve not just looking at water management for these dams in the western United States, but actually across the entire United States, because it improves our forecast scale for everyone.
Wow. So you mentioned water reliability. So one of the major benefits we've seen, or you've seen in your pilot programs, has been water reliability. Can you tell us a little bit about some of the success stories with increased water reliability? Yeah,
so that's a key point here is that what we've come to understand is that at any given dam in the West, there was a very careful study done to determine, all right, how much water supply can we safely have in the wintertime when it's rainy in the West? And then how much room do we need to be able to store a potential flood? Those were carefully worked out. And in some cases, maybe some of the hydrologic conditions or maybe some of the other things have changed. And so from time to time, the Corps will embark upon a study to update what's called the Water Control Manual, right? And that's the manual that has within it a water control plan that carefully lays out the balance between that at different times of the year. Sometimes it's constant. Other reservoirs, it's going to have a seasonally varying balance between water supply and flood risk management space, and other authorized purposes too, right? It could be hydropower,
That's right.
It could be for ecological purposes, could be for recreation, it could be for any number of things. And so those balances were carefully worked out. So what we're talking about with FIRO is not necessarily moving that boundary, but we're talking about, can we make it more reliable that we have that water supply available, or for whatever purpose it might be, right? It might be for ecological purposes, keeping the flows at the right time of year so that the spawning fish have enough water to make
That's
it
right.
migrate upstream, or temperature control for releases as well. All of those factors come into play, and so we need to be able to study that in great detail at each individual reservoir to be able to figure out how can we find that better balance. And so we want to make the water supply, and we use that term kind of generically there, but it, for whatever purpose it might be, maybe it is for recreation, or maybe it is for hydropower or ecological purposes. Can we make it more reliable in the sense that we're not just always retreating to safety of saying, oh, well, no, we got to get rid of that water because there might be another storm. Well, if we can look a little bit ahead, using our, I'd like to tease our meteorological colleagues that, if they gave us a weather crystal ball, we could really manage water a lot better. That's what the water management community within the Corps of Engineers has taught me. Is that, yeah, you give us a weather crystal ball and we'll be able to manage water very well. So they haven't quite given us a weather crystal ball yet, but the forecasts have there's been significant improvement in the forecast skill, let me put it that way. And because of that, water managers now have more confidence in the decisions that they're making to keep that water a little bit longer when they don't see anything coming. I want to emphasize that a little bit, that isn't going to be true everywhere in the United States, right? Here we are in the summer in Mississippi right now. We have convective systems that can drop rain on, a bunch of rain on a watershed in an afternoon with very little predictive skill. I mean, just the other night, there was a bunch of rain that we ended, that morning there wasn't any forecast for. But in California, that doesn't really happen very much. In fact, really never happens that they get that kind of rain showing up out of nowhere. Certainly not in the time of year that when the rain does show up there. So a clear sky forecast in certain parts of the country is a very solid forecast, and one that water management can rely upon and make their decisions based on. And so they may be storing some extra water because there's not any need to release that in the weather forecast. And so figuring out how to safely do that, how much can they store extra, and for how long, and how much lead time do they need to be able to see when a system might be coming that would cause them to need to release, and get back down to that same level that they had before. Or maybe if it's a really big storm coming, even increase the amount of flood risk management capacity than what they had previously. So FIRO can actually help on both sides of that equation, right? Improving the reliability of water supply, but also improving the flood risk management capacity, as well as might it be for other ecological or hydropower or whatever those purposes might be. That's one of the key ingredients that we found from this FIRO exercise is that it's not a zero-sum game, that if one wins, the other loses, that you actually can benefit all the authorized purposes at a reservoir if you're incorporating better forecast capability into the equation, because it gives you enough lead time to be able to manage the water better. So as the General Spellman came up with the tagline for FIRO that I use now on all my presentations, managing water before the first drop hits the ground.
Yes.
And that was General Spellman who came up with that. I can't claim credit for it. And so that represents actually a very important difference in how the Corps manages water, because literally up until May of 2016, Corps policy for water management, the engineer regulation that governs water management within the Corps, literally said that we would manage water to the principle of water on the ground, meaning measured precip or measured snowpack. So in other words, not forecasts. They were by policy was not allowed to be explicitly used in water management. But that policy was changed in May of 2016, and now it says we can use forecasted conditions for planning future operations. So FIRO literally is the R&D effort to figure out how to effectively and safely do that, and do it in a way that it's codified and actually written down in those water control plans within the water control manuals.
And so would that be determined by the codified framework? Would it be generic for all reservoirs? Because it seems like it would have to change depending on the reservoir.
Exactly. And that's really another one of the key factors that we've found in this report. We didn't. It wasn't a surprising finding. That was as actually something that we very much expected to be, but it has been borne out. And it took a little bit of discussion with Congress. They thought, hey, we'll just give you some extra money to figure this out and we'll be good, right? And we said, well, that worked for one reservoir. Now we have to figure out how to take it to the next one. And much like children, right? They may look alike, they may have the same, genes and everything, but they're going to be very, very different individually. Every reservoir, no matter how much they look similar on paper, they may be in the same watershed, they may be have many of the same characteristics, but they all have their own unique attributes to them. And as we talked about, each one might have its own unique set of authorized purposes.
Right.
It may also, and very likely, has different parameters, different release capacities, different downstream channel issues. So all of that has to be taken into account. And so that harkens back to what I said at the beginning about that we carefully form these steering committees with representatives and senior enough that they can speak for that agency, but also still get down into the technical weeds if needed, to investigate what all the different factors are that as you try to apply FIRO at a particular reservoir, you have to consider what all of those factors are. And they need to be discussed openly and I'll say this in a non-threatening way. Many times, these agencies and stakeholders, they talk to each other on a regular basis because they have to, right? Right. They talk about, different factors, and the Corps might be updating about, hey, we're planning on making this change, or this is what current conditions are like. Other agencies might be talking about, what their particular updates are, and usually when they get together and talk, they're updating each other, but there's a little bit of I don't want to say adversarial, but there's a little bit of we're defending our interests, you're defending yours. There's a bit of an assumption that the other group's not taking your interests into account because that's not their job.
That's right.
And so there's a bit of an adversarial type of a tenor, if you will, to those types of conversations. With FIRO, we've worked very hard to change that dynamic because since it's an R&D exercise, we don't know what the answers are. We don't know what's possible. So we're just trying to see what will the science support. So we want to make sure that all of the different interests are represented around the table and that all of those perspectives can be talked about openly and without threatening one another in terms of what their interests are, but to make sure that we're discussing it in a way that allows us to be able to investigate what all of the different possibilities are and do it without, we don't know what the answers are. We don't know what the science will support. So we want to try everything from A to Z and try and break the system and find out what does the science not support anymore. And we know what the limits are. Maybe that's an avenue for future research, right? If we could improve it a little more over here or improve it a little more over there, then we have some more room to operate. But we're trying to find out how much flexibility we, the Corps of Engineers as an agency, will support, but also other perspectives, other agencies from their interests and their whatever their particular interests are, that those are all able to be supported by what we end up with as this is a viable scenario. This right here allows the maximum amount of flexibility from all of those different perspectives And then that we're going to actually codify that and put it into the water control plan within the water control manual, so that now the operators feel safe, that they're protected, they're covered by being able to operate within that that zone of flexibility, if you will.
Absolutely. So I want to remind the audience that you are part of the conversation. And so if you have questions for Dr. Talbot, please go ahead and put it right there in your comments, and we will be asking those in just a moment. And so I wanted to ask you, you talked earlier about the fish and the ecological management. And so can you tell us a little bit more about how FIRO plays into that?
Yeah, so it really comes down to, again, what the particular issues are at that reservoir. So Lake Mendocino, our initial pilot, there's a biological opinion about releases from that reservoir, because there's 3 different kinds of salmonids that spawn in the waters downstream of the dam. And so trying to optimize for, when can those releases happen in a way that are beneficial for the fish in terms of what their natural cycles are of when they expect to be able to migrate upstream, and that. Also with temperature control, right? Mm-hmm. The release, if there's more water behind the reservoir, then they have more opportunity to keep the temperatures in a range that's better for the fish. And then also changes, right? The ramping rates, as they call it. Right. So if they have to, because a storm's coming, or maybe that there's, had just been a storm and they want to change the releases, you can't just, blast it out. All of a sudden you need to ramp it up or ramp it down, again, based upon what's good. And so National Marine Fisheries Service, NMFS, is the regulatory agency for that. It's part of NOAA. So they're represented on the steering committee at Lake Mendocino as well. So those communications and lines of communication happen between them. And I want to point out one thing that this happened early on in the FIRO process, and it was something that at the time I didn't realize how significant it was, but it struck me that we were making some good progress in this steering committee approach, because at one point when we were talking about different operating scenarios at the reservoir, the operators from the Corps, right, the water managers, they suggested, hey, if we did it like this, that'd be better for the fish, right? And they were speaking to the NMFS representatives, who almost fell out of their chairs, because they're like, wait a minute, the Corps is trying to accommodate us. But that to me was one of the side benefits, if you will, or one of the key benefits of FIRO is that we're actually getting this understanding between agencies. And the Corps operators knew that they were going to meet their flood risk management objective just fine. But if they operated a little differently, not only is their benefit met, but also the benefit for the NMFS. So why wouldn't they want to do that? And so that builds this institutional trust between agencies that is, I think, one of the, I like to say, one of the hallmarks of FIRO is that it helps to build that trust between these stakeholders, so that they can figure out a better way to operate together that's not going to threaten anybody, but it's actually just going to see how much the science can improve the flexibility and provide that benefit to other agencies. I'll just quickly mention also that we have another pilot in Southern California, Prado Dam. Downstream, there's no issues. In fact, it's almost basically a concrete line channel from there to the ocean, and it's very close to the ocean, so there's really no downstream issues. For there, it's all on the upstream side, because the reservoir tends to not have a pool behind it. It's technically what the Corps calls a dry dam. It does catch water, obviously, when it rains, but there's the area that would be inundated if the reservoir were to fill up is most of the time essentially a forest. That's kind of a term I'll use loosely. It's mostly just kind of scrub vegetation in that. But there happens to be an endangered species songbird that nests in those at certain times of the year. And so the ecological issues there are not on the downstream releases, but they're on the upstream dealing with a songbird. So you never know quite what you're going to have at any of these reservoirs. They could have very different ecological perspectives. But all of that needs to be
unique.
Yes, indeed.
And looking, as our children would say, looking for the win-win of trying to find benefits for all the people at the table. Right. And so that's really important. So FIRO relies on weather and hydrological forecasts. So you talked about that, about how we're no longer holding the water managers accountable for just the water on the ground that we're now going to be looking at forecasts, such as rainfall, snow melt, stream flow. Can you tell us a little bit about some of your knowledge sharing partnerships? So you've already gotten into that. You've already spoken about that, about how we have all these people at the table and they feel like there's a trust and the knowledge sharing. So can you dive in a little bit more on the variety of agencies and including local? So how does all that work?
Yeah, in fact, I really can't stress enough the importance of having those local champions, if you will. Usually their interest is, hey, we're going to get, maybe some more reliable water supply out of this, or maybe it's for the, ecological purposes. And so they definitely have interests. And we talk very openly about what all of those different interests are. In fact, that's one of the key things is that we make sure that we share those different perspectives and understand what are the constraints, whether it's time of year or maybe what's the operational constraints at the reservoir, what its downstream channel release capacities are, whatever those factors might be. But having that understanding from the local water agencies, as well as from the Corps of Engineers district itself, whoever is responsible for those operations. I'll use Prado Dam again. Mostly a concrete line channel from there to the ocean, but there's a long list. They have to have about 24 hours. If they're going to change the releases out of the reservoir, they have to have about 24 hours of notice to all of these different groups and agencies. Wow. There might be unhoused people that need to be cleared out of the floodway. There might be construction. There might be movie sets. There might be all different kinds of things happening. And so it's again, very complicated depending upon the site and the particular issues. Prado Dam's in an urban area, so you have a lot of different kinds of things happening. More rural areas, they're not going to have as many of those issues, but there may be very, other factors that need to be to come into play there. And the local agencies are very attuned to what those are. And so having their support behind this and having them feel like their voice is heard, right, that they're represented in their interests are being discussed and looked at. We use kind of a two-step process as we assess viability at any given reservoir. We call it a preliminary viability assessment, or PVA for short, and then a final viability assessment. In that PVA process, we look at kind of all kinds of crazy scenarios that probably we would never really adopt in the end, but we want to see where it breaks down, where, right, trying to break the system, so to speak. Where does the science not support that level of flexibility? But from that PVA process then, and that's where it's important that, again, all of these different groups or stakeholder interests are represented and feel like they can express what their constraints or concerns or desires are from changing the way that the dam currently operates, to explore all of that space. And from that PVA process, we'll distill it down to, okay, so these are the realistic scenarios. This is what the science will support, this much flexibility, this much, these kinds of changes. And then we'll take that to that FVA process, the final viability, where we'll test it in great detail and run it through a whole battery of tests in terms of like extreme storms that have been seen at that reservoir, plus other ones that we can, foresee that might happen there, and convince ourselves as an agency as well as other agencies that we're comfortable with that level of flexibility. And then that's what can be passed off to the district to actually go through the process of updating the water control manual. FIRO, the R&D part, doesn't update the water control manual. Right. Well, we set the district up to be able to actually go through the water control manual update process and put it into, codify it, put it into writing.
And how they actually go through and do it.
Yeah.
And so how does FIRO consider the various factors, so you talked a little bit about this, such as the current reservoir state storage, inflow conditions in the watershed, and forecasted conditions recommended for optimal operational decisions? So you have a lot of drivers, a lot of factors that go into this optimal operational decisions. So how do you collect all that information, and how do you identify all the factors?
So the good news there is that, again, most of these dams are not new. They've been there for a long time. And so a lot of that data are already being either have been identified or being collected or being looked at by the water management team as well as others, right? And so within the state of California, for example, there's something called CDEC, which is the California Data Exchange Center. So they provide a central repository for a lot of this kind of water resources data that are needed. However, that doesn't mean that everything that would be nice to have exists. So part of the FIRO effort has been that within a particular watershed where we have a pilot study going on, we make investments to improve that by adding additional weather and hydrological stations around the watershed to, in data gaps or where holes where the water managers say, hey, it would be really great if we had some data from that part of the watershed over there. So can we get a site put in there? And it's a relatively modest expense for the value that it could provide to the water managers in terms of making their decisions. So having data from around the watershed of, if the soil's really dry and you have a big storm coming, you're probably not going to see a lot of that end up as runoff into the reservoir because it's mostly just going to go into the ground. So that's useful for them to know. But if the opposite side of it, if the ground's really wet, even a modest storm might cause significant inflow. So having their ability to be able to see all of those different data sources is vital. Now, on the meteorological side as well, the same kind of thing is happening, that improving our forecastability further out into the ocean, because in the west, that's where these storms are coming from. All the action is happening out of the Northeast Pacific. So something that our colleagues at the Center for Western Weather and Water Extremes, or CW3E as we call them, have done is that they have worked together with NOAA and the Air Force hurricane hunters. Actually, they've kind of changed their name now. They don't just hunt hurricanes. They actually hunt atmospheric rivers now too. In the wintertime, when they're not hunting hurricanes, we deploy them to the West Coast. So an aircraft out in Hawaii, as well as aircraft along the West Coast, so that when these atmospheric rivers are forming out of the Northeast Pacific, they're able to go out 5, 4, 3, 2 days ahead of time and fly over them. Atmospheric rivers are low, remember? So they can fly high above them, deploy their instruments, which are called dropsondes. It's the same instrument that goes up on a weather balloon. When it's dropped out of an aircraft, it's called a dropsonde. It floats down on a little parachute, takes about 15 minutes to get to the surface of the ocean, and it records all the data that are needed to improve the global weather models that are running constantly. They see that data out there, they grab it, ingest it, and it helps improve the forecast skill for all of the global weather models as these atmospheric rivers are forming. And studies have already shown that going through that and having these data points out there in the ocean where we didn't have data before is giving us up to 3 or even 4 days of improved forecast lead time. So for a water manager, again, it's not quite a crystal ball, but it's getting closer. And it gives them more confidence that they have a good idea of what's happening 5 and even 7 days out rather than just 1 or 2 days out, which is a lot less flexibility and a lot less time and a lot less opportunity to be able to manage water.
And having those knowledge gaps filled and knowing that you have that data, that also has to reassure the team that the answers you're coming up with are reliable.
Exactly.
That this is reliable information because you have looked at the different knowledge gaps and trying to fill that in of the operator saying, hey, it'd be really great if we had this information over here, and the ability to go ahead and do that, and the ability to improve your forecasting obviously helps with a more reliable answer that people can feel confident in. So I want to remind our audience that you are part of the conversation, and so just put those comments, those questions right in your comments on LinkedIn or YouTube, and I will be asking those questions shortly. So can FIRO be used to increase hydropower generation efficiently?
Sure. Like any other authorized purpose there, if that's a driver, if that's something that is of import there, it would be incorporated into the mix as we go through that PVA and FVA process where we're assessing the viability of FIRO at a particular site. Many of the dams that we're already looking at right now, the pilot sites, do generate power. Sometimes it's mostly just kind of as a side benefit. It's not really a main authorized purpose or a main driver there. But if that were a major factor, and in fact we're now progressing into the Northwest. We're looking at the Willamette Valley in Oregon, as well as the Howard Hansen Dam on the Green River in the Seattle area. In both of those cases, hydropower is a little more important, and so that will be in the mix as we look at it. But yes, we can optimize really for anything that are authorized purposes at those reservoirs.
And so you spoke earlier about FIRO, how it was born basically out of this drought, out of this national crisis,
right.
and how there was a pressing need on what do we do about these droughts, and it has evolved into this framework of changing how we actually release water out of reservoirs. So can you talk a little bit about how, when this originally started, yes, we had atmospheric rivers, and yes, we had droughts, but now it just seems like there's a lot more of it, and to the extreme, you have these weather whiplash situations. Yeah. So can you talk to us a little bit about how FIRO can be flexible with these weather whiplash situations that we're seeing, especially in the western states?
Certainly, and that, it's a very timely question just because of the winter we just had in the West, which was preceded by, from 20 to 2022, was actually now the driest period in California history.
But it was back then. Right. It's replacing.
Right, replacing the 2012 to 2015. And interspersed between that and 2017 was a really, really wet year in California. In fact, at the time was the wettest year on record in Northern California. So, yeah, we've certainly had these whiplash or weather extremes. It's great that we have this Center for Western Weather and Water Extremes, right? Very appropriately named. And so I want to stress that FIRO is not necessarily came as directly because of climate change we're doing FIRO. FIRO is the right idea because of forecast skill improvement.
Absolutely.
Right? And so whether or not we were having extremes or not, FIRO is definitely a way to make sure that we're taking full advantage of what the science currently supports. However, it's good that we're doing it because it is a climate adaptation strategy that is very timely. Short of building a new dam or making a dam taller, or what other structural changes might be, all of which are very costly and take a lot of time to enact. FIRO is, with a year or two of study, we can actually figure out how to more flexibly and effectively manage our existing infrastructure. Right? Not a single bucket of concrete has to be poured for FIRO to take effect. Now, there are some sites that are actually looking at some structural changes. So one of the dams, New Bullards Bar, is talking about adding a secondary spillway that would allow them to be able to manage, again, with the idea of being able to manage for those flexible situations and put it a little higher so that they can
have more flexibility.
Right, and so that when they see a large storm coming, they can do more, and not having to wait till it gets all the way down to the lower level. They can actually manage when it's up on that higher part of the reservoir capacity. And so those are strategies that every agency has to kind of look at that and do the cost-benefit analysis to see what's possible there. But because the forecast skill is improving, and we're figuring out how to incorporate that into the flexibility into the operations, that's allowing more climate change adaptation strategies to be able to be possible and put into effect.
And so looking forward, what are your next steps in this research? Where do you see FIRO like 5 years from now? What efforts are being made?
Great question. So we're actually entering phase 3 of FIRO this year. Phase 1 was just figuring out how to do it at Lake Mendocino. Phase 2 added some additional pilot sites, and then from that we built what we call a screening process. We were able to determine, okay, so at these sites here, these are the characteristics that make a good potential FIRO candidate, because not all dams it's going to be possible there for various reasons. So how do we figure out how to go, to evaluate the Corps' portfolio of dams has about 400-ish plus dams that have a water control manual. So of those 400 plus dams, which ones where should we take this next? So we developed that screening process to help us. So part of phase 3 will be taking that screening process and looking all the rest of the dams across the United States that the Corps owns and operates, or has a water control manual obligation through a Section 7 responsibility, and decide, okay, so we'll screen them through this process and decide these are the really good candidates, these are kind of the maybe, or maybe we need some more science to improve, and then these down here maybe not, for whatever reason. So that's part of it. Then the other thing will be, as I mentioned, the Willamette Valley in Oregon, right? Mm-hmm. That is a really good example of a system of dams. You have 14 dams in that watershed. Wow. 13 are owned and operated by the Corps. Some are in series with each other down, multiple dams on a single river. Others are arrayed around in the watershed and kind of in parallel, if you will. They operate all of those dams from a single office. They don't have them each have an individual water manager who is making their own decisions. They actually operate it as a system. And so exploring FIRO's application in that kind of a setting is different. And there's other systems around the country that we need to look at. So exploring systems and figuring out how FIRO works in that's part of it. And then, we've again focused in the West. That's where the interest came from. That's where the need was the greatest. We haven't looked at other parts of the country yet in great detail. We've had some nibbles. We've actually been having some discussions up in the Northeast as well as Southeast and in the Southwest area around in Texas and that. So we will certainly be looking at how we apply FIRO in those areas as well. There's much that the FIRO team within the Corps has to learn about interest or the particular issues in those parts of the country. There's where we would be relying upon those water management teams across the Corps who are experts at their own systems, and they know what all the issues are. They also know how good the forecast skill is. They have a really good feel for that. And what I've learned is that many of the water managers around the Corps, they've been looking at forecasts for a long time.
Right.
And they've been wanting to do, or maybe even somewhat are doing a little bit of kind of FIRO. FIRO is there to help them have some defense and some backing on this much flexibility is how much the science supports and how much we as an agency are willing to stand behind and say, yeah, we're going to put that into the water control manual.
Very good. And so our first question from the audience actually has to do with the water control manual. So this person asks, how often is the water control manual updated? Are the guidelines outlined in the manual part of FIRO algorithm?
So great question. So as by policy, actually, all water control manuals in the Corps are supposed to be evaluated and updated if needed every 10 years, right? And so there's already a schedule for that. Many of these water control manuals, like Lake Mendocino, was first written in 1959 when it was built, but it's been updated multiple times, mostly minor updates, but now it's actually getting a full FIRO update because of the viability assessment that's been concluded. Actually, Lake Mendocino's is done. It's been all the way through the FEA process. That water control manual should be updated by December. We hope it's being finishing touches being put on it right now, and it will go through its official review and all of that process here, and we hope to have it in place by December, maybe January. Wonderful. So so the other parts, parts of the country, there's congressional interest in seeing FIRO implemented, and they understand that, and so they know that they have to provide that funding to the Corps to be able to look at water control manuals. Not just by age. That's not a really good determinant as to whether or not a water control manual is to be updated. It needs to be updated based upon if the conditions have changed. Whatever the original assumptions were that from how it was originally written to today, those may be different. And so that's where you have a change needed. And right now there's an effort, Congress funded this year, an effort to prioritize, not just for the West, but for the entire United States. And so there's an effort ongoing right now to make that prioritization list, and that will really help us from the FIRO aspect to be able to say, okay, this priority list, let's look at them from a FIRO perspective as well and say, all right, so which ones are good candidates for FIRO? And there's where we might need to target next efforts.
For the next pilots. Mm-hmm. So the next question from the audience is, reservoir management takes on a different dimension when it comes to hydropower generation interest. Is there a condition with the Energy Department for integrating FIRO as part of FERC licensing, or just operational decisions?
Yeah, so again, at every reservoir, you're going to have a different set of constraints or interests that need to be taken into account. And so FERC is the regulatory agency that governs hydropower and other types of energy generation. And so at a particular reservoir, if that's a key factor in how that dam is operated, not just from a flood risk management perspective or any other particular authorized purpose, then absolutely they would be brought into that discussion, right? And so we would have representation of that interest on the steering committee to make sure that when we're looking at, through that viability assessment process, both the PVA and the FEA side of it, that we make sure that that's brought in and looked at, because the questioner is absolutely right. That could really drive the release decisions. And so it's not so much, at a reservoir where it's only there basically to catch rainwater and then maybe use it for water supply. It's a little bit of a simpler equation. But when you have hydropower and in fact, I mentioned the Willamette system again, where you have all of those dams. Some of them, it sounds like 14's a lot in a basin. It is, but sometimes they have pairs of dams. The downstream one is there to just catch the releases from the upstream, because the upstream one is being used for power generation. And so it kind of pulses its release. They generate power when it's needed, and they don't at night. And so it sometimes is releasing a lot, or sometimes hardly any. And the downstream dam just catches all of that and re-regulates it. It's called a re-reg dam, right? So it just basically smooths out the flow, so you don't have this up and down nature all the way down the stream. And so if you have that kind of pairing of dams, then how does FIRO play into that? Well, we're exploring that now.
That's great. So the next question from the audience is, what are the challenges with adapting FIRO for Mississippi Valley projects that are more impacted by thunderstorms, as you mentioned earlier, opposed to atmospheric rivers?
Yeah, so again, that goes back to what we talked about earlier on, that at certain times of year, especially like summertime right now, convective systems, forecasters, meteorologists, if they're being honest, they'll tell you there's very little skill in that. And so that presents a challenge from a FIRO perspective. Now, but what can you do about that? Well, first of all, most of those dams are built with a very large capacity anyway, because that's a real challenge, right? And that's something that was taken into account when that dam was designed, and the water level set for the boundaries between what we call conservation and the flood risk management side of the reservoir. So that's one benefit. The other thing is that there are certain times of year, right, where the weather is more predictable rather than the convective systems, right? So even here in Mississippi, we get impacted by atmospheric rivers. You may recall in February of 2016, we had a major flooding event in Monroe, Louisiana, right? That was an atmospheric river. 3 days of solid rain there. 25 inches, I think, was about the peak. Shreveport and Vicksburg, which are about equidistant from Monroe in either direction, we had about 10 or 11 inches of rain both places. But that atmospheric river was centered right on Monroe. So improving the forecast skill for those types of events, that's where dams in this part of the country could also take advantage of that. And so maybe FIRO is not possible in the convective time of year. If again, the viability assessment would bear that out, right? We'd be able to investigate that and say, okay, if forecast skill for that time of year is really low, we may not be able to operate to FIRO in that type of time of year. But other times of year, there is skill in those forecasts, and we can see those events coming. By the way, the hurricane hunters and that, they don't just, we have them only on the west. In the wintertime, actually, this past winter, we had to also fly some missions off of the Gulf Coast because atmospheric rivers were coming across that, and we can fly those as well and improve that forecast skill for the East Coast and the southeast coast.
Fabulous. So another question from our audience is, you mentioned that each reservoir is unique and needs to be treated independently in assessing its suitability for FIRO. But has anything been learned that commonly that's commonly applicable for assessing new reservoirs? Have you seen a common thread?
Yeah, certainly. And that's where that screening process actually captures that, because as we've moved from the pilot to pilot to pilot within in the West right now, we have learned a lot about what are good factors that go into that. One of the key ones right off the bat is just what's the travel time. Right? Yeah. From the releases from the reservoir, how long does it take for that water to get past the control point or the downstream most flood-prone area, or in the West, it's usually the Pacific Ocean. And so that right there is a quick calculation, right? So from Lake Mendocino, it's like 1 to 3 days of travel time for that water to get all the way to the ocean. Then how much time would you need to actually get rid of the, if we're talking about 10% extra storage, which was kind of our target from the beginning at Lake Mendocino, how many days of release time do you need? And then the travel time. And that's where we came up with the 4 to 5 days lead time that we needed. 4 to 5 days in the West for forecasts, that's pretty solid. The forecast skill is good now for that kind of thing. Other parts of the country, that may not be the case. Right. Or you may need longer travel times, right? So let's
where it's located. Right?
Exactly. If we go to, say, Texas, let's say Southeast Texas, the Brazos River or the Trinity Rivers, they have longer travel times from their dams. And so now you need more lead time in that forecast. And plus the fact that you've got major population centers at the downstream ends of their rivers. So you can't really be, you can't be releasing and flooding out an area that's important. We're a flood risk management agency. We manage for floods. We try not to cause them. Exactly. So
absolutely important. So can you discuss how FIRO evaluates sedimentation rates within the reservoir and prescribes sediment bypassing or other alternatives?
Yeah, so that's actually an active area of research, sediment bypass and sedimentation in the reservoirs. Because we have that research ongoing within ERDC and within the Corps, FIRO, we're not actually investigating all of that sediment stuff. We kind of have our hands full with with just the meteorological and hydrologic side of FIRO, but we have access to that expertise that's ongoing within the Corps. There's actually quite a bit of capability there, both in the science of that, understanding it, and what different technologies are available to help deal with sedimentation, but then also it's being built into the modeling capabilities that we have for the simulation. So if that's a major issue at any of the dams that we would be assessing FIRO at, we would be able to access that expertise and the modeling capabilities to incorporate that into the viability assessment process, because that would just be all part of the mix that as you look at a specific reservoir.
And I think that's one of the things that I like most about ERDC, or what we call the power of ERDC, is leveraging our colleagues that maybe we don't work with every day, but we do have those capabilities in-house and can reach out to them if needed to be, based on each project.
Wildfire, post-wildfire hydrology is another factor here, right? Many of these watersheds in the West experience wildfires and intense wildfires. And so I haven't mentioned it up till now, but the atmospheric or meteorologist side of things, they've actually, with understanding the atmospheric rivers, they've actually developed a scale with them, much like a hurricane scale, right? Intensity scale from 1 to 5. And it's based not only on the intensity of the how much water vapor there is and how fast is it moving, but also on the duration. So it's a two-dimensional scale that looks at those factors to say, okay, this is an AR1. An AR1 or a 2, that's mostly just going to be beneficial and wet the watershed and fill up the reservoirs. 3's kind of on the border between that and damaging floods. 4's and 5's, now those are the biggies. Those are the ones that you can expect to have damages, mudslides, severe impacts to population centers, and therefore there might need to be emergency management preparations and that. And so this scale actually provides emergency management benefits, but also helps water managers to say, oh, it's not just going to rain a lot this weekend. This is a Category 4 storm. I need to be
prepared.
Need to be prepared. And maybe I even need to release ahead of this enough to give myself even extra flood risk management capacity. But when you factor in wildfires into that, maybe now a Category 1 or a 2 storm, which would normally be just beneficial, might now actually act more like a 3 or a 4, because it's hitting a watershed that isn't able to absorb the water like it used to. And so tying those two research efforts together, again, reaching to this power of verdict concept, that's an area that we're exploring right now, is that, okay, so now we understand ARs better, and we can predict them better, and we have this scale. Can we tie that to the wildfire hydrology research to make sure that we're providing even more benefit to emergency management, preparation, and water management decision making?
Wow, I love the power of verdict and the different applications and the different expertise and capabilities we bring to the table. So, does FIRO currently have a way to measure soil water content?
So that technology is something that is well used within the hydrologic community, right? There's different kinds of sensors on that. And so, yes, we, within the watersheds that we're studying for pilots studies, we make investments to have increased monitoring done within the watershed. Some of them had really good water monitoring already, but if you ask the water managers, they'll pretty much always be able to tell you, yeah, over there would be a really great spot to have another one. And so and so if we can, again, you got to work out the agreements with the landowners and other such things. It actually helps to have it not be the federal government. We'd have our university partners go and do it, because sometimes if it's the Corps of Engineers coming in, Uncle Sam wanting to put a station there, the landowners will say, go away. But if it's a university, then they tend to be a little more amenable to that. And so we've been able to have some really good opportunities to increase the understanding and the visibility of soil moisture or hydrometeorological concerns in data around the watershed.
Wonderful. So our last question from the audience: what are some of the areas of the country that seem to be strong candidates for a FIRO expansion?
Okay. So again, it all comes down to what's, each individual dam site, right? You could be in a great part of the country in terms of forecast skill, but because of the particular issues at that dam, maybe not.
Right.
But just speaking in terms of forecast skill, because that's usually the biggest driver, right? The travel time from the reservoir to the ocean is going to dictate how much forecast lead time you need. And so that's oftentimes the biggest driver of suitability for FIRO at a particular area. And so the West Coast has the best forecast skill. That's just hands down. They don't get surprised by rain.
Right.
Now, whether it hits your particular watershed or not, it's another matter. But when it's clear sky forecast, that's solid in the West. The Northeast actually has the next best. And this is based on a study that was done a little more than a decade ago, actually, looking at all the different, both seasonality, dividing the year up into 4 chunks, and seeing which parts of the country had the best forecast skill. We're able to, based on looking at the false alarm rate, as well as being able to predict the actual rain that fell. But that study is a little bit old now. And so part of phase 3 will actually be a nationwide re-evaluation of forecast skill to, again, help us identify where they're at. So the next best area is New England in terms of forecast skill. And again, it depends on the time of year exactly. But New England's got a pretty good track record on that so far. Will be interesting to see how it plays out with this re-evaluation of that forecast skill. But there's other parts of the country too that have good, again, might be different times of year, but there's other areas of the country where we can look at that too.
Wonderful. So I'm going to remind our audience that if I did not get to one of your questions, we will try to respond to those. And also, if you have questions, if you're watching this after we've gone live, you can always submit your question to erdicinfo@usace.army.mil. And that, again, that is erdicinfo@usace.army.mil. Shoot us a question, or if you have a question about anything that you've seen today, we will respond through that email. And so, Dr. Talbot, thank you so much for taking the time to share with us about this important R&D and how it is solving some of our nation's most complicated challenges. And between now and then, if you want to learn more about some of ERDC's R&D, you can also listen to our podcast, powerofERDC.org, on any of your podcasting platforms. And so look us up, powerofERDC, podcast.org, and you can listen to the latest R&D. Until next time, when I see you in July for our next broadcast, find your joy. We'll see you next month.